Okay, today we're going to look at Maclaurin expansions. So, first question is 2016, question 6. Okay, so we have to do the Maclaurin expansion for sine 3x and the Maclaurin expansion for e to the 4x. Now you get this given on the formula sheet, which is helpful. And basically, it shows you what you need to do. And obviously that continues. So if we concentrate on sine 3x first of all, so f of x equals sine 3x, you'll see that we need to find f of 0. So that's sine of 3 times 0, so sine 0, which is 0. We also need f dash 0, so if we find f dash x first of all, now this is a chain rule, sine something differentiates to cos something times the differential of the something, which would be 3, so 3 cos 3x. Then you can find f dash of 0, so cos of 0 is 1 times 3 is 3. F double dash of x, so again chain rule, cos something differentiates to minus sine something times the differential of the something, which give us minus 9 sine 3x. Subbing in 0, sine of 0 is 0, so that's going to be 0. And then the third derivative, sine differentiates to cos, so chain rule again, minus 27 cos 3x, and subbing in 0 to the third derivative is going to be minus 27. So all we need to do now is substitute that into the Maclaurin expansion here. So sine 3x equals f of 0, which is 0, plus f dash 0, which is 3 times x, 3x, plus f double dash, second derivative 0, x squared over 2 factorial. And 2 factorial, remember, is just 2 times 1, which is 2. So we're going to have 0 x squared over 2, which is going to be 0. And then we've got the third derivative with 0 substituted in, which is minus 27, and it's x cubed over 3 factorial. Now 3 factorial is 3 times 2 times 1, which is just 6. So over 6 plus ... Okay, so simplifying it, sine 3x equals, that bit's 0, 3x, that bit's 0, and then we've got minus 27x cubed over 6, ... Just simplifying the 27 over 6, we can divide top and bottom by 3, and we'll get 9x cubed over 2, and that is it, simplified. So that's us worked out what the Maclaurin expansion for sine 3x is, and all we need to do now is the same for e to the 4x. So we're now starting with f of x being e to the 4x, f of 0 would be e to the 0, which is 1, f dash x, a chain rule again, which is 4e to the 4x, and subbing in 0 to that bit's going to be 1 times 4 is 4. Second derivative, chain rule again, 16e to the 4x, and subbing in 0, The exponential part is 1 times 16 is 16. And then we need to do our third derivative, which chain rule again, 64e to the 4x, and sub in 0 gives you 64. So you're then substituting that into the Maclaurin expansion there. So this time we've got e to the 4x equals f of 0, which is 1, plus f dash 0, which is 4 times x, plus 16 x squared over 2, plus 64 x cubed over 6. And all we need to do is simplify that. So 1 plus 4x plus 8x squared plus 32 over 3 x cubed plus dot dot dot. So we're almost there. So that's us done the expansions for sine 3x and e to the 4x. And what we're now going to do is multiply those two expansions together, because we now want to work out up to and including the term